So the quick agenda for tonight is just going to show the introduction. We've got Matthew Clark from the Voxel Agents over here, talking about hardware texture compression, GPU, and Maxim over here, talking about appliances for Android. So quick Android news. This is pretty much the calm before the storm for Google I/O. Does anyone here get tickets? No, neither did I. I don't know anyone yet who did. Also, the Play Store turns 1 now. I guess that's important because I think that was the big turning point where Google actually turned around to actually try and push Android as a consumer product. And I think that's reflected in Google Keep as well. So, which, if anyone doesn't know, Google Keep came out recently. Try it out. It's pretty cool. It's just note-taking and stuff, but it's quite nice the way it syncs across your Gmail account. Alright, so I'll let Matthew up and hopefully this will go up that page.
Cool. Hi everyone, my name is Matthew Clark. I'm a programmer, as you can see by my horrible lack of art in the slide. I'm a game developer by trade. Made a few games. Started a company a few years ago called the Voxel Agents. So, who am I? I got my first job in Brisbane at Pandemic Studios making games for the Wii. And my first day of work, I was thrown in right to the deep end. I had to write the texture compression algorithm to work on the Wii with the Wii's proprietary hardware. So that was pretty interesting. And it took me like a week, and probably the guy who was teaching me how to do it would have taken him a couple of hours. But, now I'm that guy, hopefully. And then about 3-4 years ago, I moved to Melbourne and started a company called the Voxel Agents with 2 friends of mine, Simon and Tom, which you can see in the picture there. We've released a few games, most notably the Train Conductor series for iPhone and Android, which has well over 5 million users, which we're pretty happy with. And just last month, we released Puzzle Retreat on iOS and Android. And I was going to show the trailer, but there's no sound, so I'll just skip over that. So my talk today is about texture compression. So it's a solved problem, right? Just use JPEG or PNG. Yeah, not quite. Different graphics cards don't know what to do with a JPEG or a PNG, right? There's lots of problems. If the graphics card can't render that, you need... Sorry. Let's go back to the basics, right? So an image is an array of pixels. So this image here just has it's 512 by 512 image. If you get that as a PNG, it's about 460K. But as I said, graphics cards don't render PNGs, they render arrays of images, arrays of pixels. Each pixel is about 32 bits, so 4 bytes. So 4 colors, 3 colors, red, green, and blue, and a transparency channel. So that all adds up to about 1 meg for a 512 by 512 image. So it's a 32-bit pixel image. So in our game, these are all the images, or almost all the images in our game. How many is that? That's 6 2048 by 2048 sheets. It's about 25 million pixels, or in pure memory terms, about almost 100 meg, which is pretty ridiculous. 100 megabyte casual game, no one wants to download that. No one has the space on their phone for that. The load times are going to be ridiculous if you're trying to load up all that memory. So we need a better solution. So why can't we use PNG? So as I mentioned before, graphics cards, you can't index into the middle of a PNG. You can't find out quickly what color that pixel is. So you need it to be stored in a big raw format. So that means you have to decompress the PNGs, JPEGs at runtime. It's really slow. When you try to load the app, it's going to take forever. And there's another problem in Android, which whenever your app goes to sleep or you switch apps, you lose your OpenGL context, which means you have to reload all of your textures back into memory. And if that's taking like 4 or 5 seconds, that's just unacceptable for a mobile game. And then there's still, even if it's compressed and then you uncompress it, it's still a massive memory problem, like 100 meg of RAM. So is there another format that we can use? So as I mentioned, the standard format, which is IGBA, 32 bits per pixel. There's 8 bits per channel there. There is another format, which is the 565 format, which is pretty good. It's 16 bits per pixel. So 5 bits for red, 6 bits for green, and 5 bits for blue. That's pretty good, but obviously it doesn't have alpha. So if you want to add a transparency into your image, you're looking at going down again to IGBA 4444. So that's all right, it's just half the size of your app. That's pretty good. What about banding? So as you can see, so this line in the middle here, that's your standard, a 4-byte pixel. 8 bits of red means there's 256 reds, so you get a nice smooth gradient. If you step down to 5 bits for the red channel, there's only 32 reds on the screen, which is pretty bad, pretty poor. You can start to see really visible banding. And then stepping down again, if you want to add alpha, you only get 16 reds, which is just pathetic. Like if you want to make a game that looks good, you need a lot more than 16 reds on the screen. So what else is there? So a bunch of smart people a really long time ago came up with like a block truncation coding texture compression method, which is basically like reducing the image into little blocks of pixels. A bunch of different names for it, like Power VR texture compression, the DirectX texture compression, Ericsson texture compression, ATI texture compression. As you can tell from the names, they're all proprietary formats. They're all really similar, but subtle differences to get around patent issues, I presume. And these are all amazing. They all give 4 bits per pixel compression. So how do they work? Roughly, each image is broken up into groups of 4x4 pixels, or 16 pixels. The first, and that 16 pixels is represented by 64 bits of information. So the first 32 bits is 2 colors. It's stored in the RGB 565 format that I mentioned earlier. And then there's 32 bits of indices. So each index is 2 bits. So 0, 1, 2, 3 gives you 4 indexes into those 2 colors. So how does that work? Like, how do we get an image out of this? Well, first of all, the color 0 and color 1 is then interpolated. So you pick 2 colors between those 2 colors. And the 4 indexes are basically indexing into those 2 new interpolated colors. So this actually gets around a lot of the banding issues because those interpolated colors can be interpolated using the full range of the, like a full 8-bit per channel image. So you can get like a much nicer, that's why we go back to the banding image, the compressed one has a nice smooth gradient. That's a really rough kind of example of how they work. As I mentioned, all the formats are subtly different, but that's the basics of it. So 4 bits per pixel, that's pretty amazing. We just saved 87.5%. A 100 meg game is now only 12 meg. That's pretty good. I'll be happy with that. It's actually not quite that easy. So as I mentioned before, we got there's 4 main formats: ATI, Power VR, the DirectX, and they work on a bunch of different chipsets. So you get the Adreno chipsets, the Tegra 2 NVIDIA ones, other ones, Power VR, which you get on iPhone, and then the ETC format, which is guaranteed by Android, which is good. So all Android phones are supposed to support that, but there's no alpha, so that's no good for us either. No good for games. So our game Puzzle Retreat, which we just released, supports 1900 devices. How did we do that? So as you can see, there's 4 active binaries at any given time available in the store. So if you were to all download the game, I would have no idea which version of the game you were getting, but you probably wouldn't be able to tell either. So that's a good thing. It all just looks like one version to the user. So just if anyone's interested, just to break it down roughly, there's about almost 1,000 Adreno-based devices, about 800 PVR, Power VR-based devices, about 500 DirectX-based devices, and then there's everything else. There's a fair bit of overlap though. Some phones support multiple formats, so the everything else is larger than 2,000 minus this one. So how do we do it? Well, good tools are the key. When we built Train Conductor, which is our old game, we built our own engine up from scratch, from the ground up. And it was designed for iPhone originally, so we just made it support the Power VR, which is really pretty simple for iPhone. They give you good tools for working with that. Bringing that to Android, we didn't want to cut our devices down to like 25% of the available devices, so we couldn't use PVR. So we just chose to use ETC1 because we didn't want to spend the resources building a system in our game to manage all these different texture formats. Yeah, pain. So our solution in the end was basically to have all the same texture sheets as iPhone. Compress all the ones we could into ETC1, and then for the alpha images that we wanted to look pretty, we then had an extra image in the game, or an extra texture sheet in the game, which had all those images that was not compressed. So how do we do it now? Well, the Unity game engine is pretty amazing. There's a little drop-down box. As you can see, it just lists the options, tick the box, bam, you've got to build. It's a little bit trickier than that. You kind of need to build good tools around it because its default settings aren't always amazing, and they don't always give you exactly what you like. RGBA 16, like I mentioned, is kind of unacceptable, so you kind of want a custom work with, like, you can add tools to Unity pretty easy to add that functionality. The only hard part is uploading the APKs. You have to do it 4 times every update. If anyone's uploaded an APK to Google and been rejected like 4 times, then although the new system is much better. So I got through that much faster than I was expecting to. So quick recap, PNGs look great. They do compress down small, but they take ages to decompress, and when they decompress, they're massive. Compressed textures are lossy. They got like really blocky artifacts. JPEG is kind of based loosely on block decoding, so you get pretty similar artifacts with the DXT and other graphics card text formats. And if you want to go into like more gaming stuff like mid-maps, you have to bake them yourself. You can't get OpenGL to do it for you. And you have to make them power of 2 and square and all sorts of other things like that. Are there many game developers in the room? So no one will ever have to do this in their life, but it's interesting. It's interesting to know, I think, just about different texture formats and how they work. I try to teach our designers this stuff, and they go a bit glossy-eyed. It's important because it's going to affect what the game looks like in the end. This is just an example of the kind of texture compression and how well you can see the artifacts. The middle image, so this is like this is a small section of a really big image. The middle image is the same as the first image, but it's compressed using the PVRTC. You get all these really ugly artifacts around the edges because the Power VR texture compression doesn't like alpha very much. It's really ugly. So there's 2 good ways to work around it. One is to do what DXT5 does, which is you effectively have 2 textures, and one texture is your RGB and the other texture is just your alpha. And then you have to write your own shader to make them appear good on the screen. Or you can do the cheap solution which we did, which is you just double the size of the texture, then compress it. It's less than half, or about half the size, and it looks almost as good as the uncompressed one. And doesn't use up any RAM, and it's really quick to load because it's in the native format, which is awesome. Yeah, does anyone have any questions about this or about our game, Puzzle Retreat, which we just launched last month?
You're basically saying you're pre-calculating all your textures to make it work with whatever the supplier might have done. Yep. Is there no mileage in basically just downloading to people the PNG and then at install time recreating the maps as required and then storing them away?
Yeah, you could do that. I guess for us, like, if you're releasing a free game, generally, at some point you want to get people to the paywall, and every time someone doesn't download your game or doesn't, continue in your game, they don't get up to a point where they can give you money. So any step that, like, oh, please download this extra image.
I just wondered if you could install, say, like the PNGs,
oh, yeah, sorry.
because they're nice and compressed, and then when you're installing, when people are not particularly paying any attention to how long it takes, you recreate the textures for their particular scenario and store them, so that basically you've only got one image then. Decompressing
these types of images is really, really fast. Compressing them actually takes quite a lot of time as well, so you don't generally want to do it on a device. It's easier for us to just do it all offline and put the native format on the device. And it works out simpler that way. A lot of assets in games are all pre-compiled anyway, so we already have a really, quite well-developed build pipeline that pre-packages all of the assets we need.
I've got lots of questions. And first of all, Puzzle Tree is very cool, but I'm still stuck in very low subs, not even up to the paywall yet. But I was just wondering, with the, the different formats, I'm assuming that each GPU is really fast at decompressing its proprietary format, versus, say, you having to have that in software so that you could have shipped one format and fed it to all the GPUs. But you mentioned that you did just ship ETC for everyone else. Does that mean everyone else didn't get alpha channel?
So everyone else gets big PNG images for the alpha images. So if I go to the very first slide, that one there. So that big flat area of color there, that's all compressed. Flat images look great compressed. Most users can't tell the difference. All those, the alpha ones, we half-size them and give them the 32-bit RGBA edges per channel. Some people's build sizes will be slightly bigger than others and use slightly more RAM.
But at least I can see.
Yeah.
compression types. Some devices support multiple.
Yeah, I'm not sure how that works either.
Well, no, then which version would be downloaded? Like if your device supports 2 of them, which one gets downloaded?
It's basically in
that's a
the
decision by the market, the Play Store.
yeah. So the Play Store manages it for you. It's basically the version number that you upload. People will just get the highest number that suits their device.
Multiple matches.
Yeah. So if you're, I don't know, you probably can't see that, but yeah, like the first one you'll get is the Adreno text conversion or the ATI text conversion. If your phone doesn't do that, then it'll drop down to DX and then the next one PDR. So then the other way around, yeah.
So it's sort of like the audio upload.
Yeah, yeah. It's all, luckily Google handles all that. There's no other way we could make this work. You couldn't have 4 different versions of your app installed.
Yeah.
There's another question.
Yeah, so it sounds like none of us are games developers other than yourselves. So what sort of advice could you give the rest of us that just use buttons and sort of bitmaps and stuff? Is any of this relevant to us?
Yeah, I think if you're making like a really sort of image-hungry game or app, it probably could be worthwhile. Of course, the flip side is if the images are really important, like you probably want them to be lossless, like or look really pretty. I guess it mostly works for, like the reason we use it in games is because we're rendering like pretty much all those images you saw. Maybe half of those are rendering at any one given time. They're all like layering on top of each other. If we were to use like non-compressed images, that would be really, really slow. That's why we compress them all to make it fast. So yeah, I think any application where either they're moving and you have shitloads of images on top of each other.
That's right.
In the proprietary formats for compressing an image, you said when it gets is it 4x4?
Yep.
And it chooses two points for interpolating the colors.
Yep.
Yeah, when it does that, when it goes back to decompress it, wouldn't you get a fair bit of fuzziness along the edges? Or I mean, the way I see this working is probably using a law of averages or some.
Yeah, there's really, like NVIDIA have spent lots of money, obviously, because it's kind of they're invested in it. Getting really good algorithms that basically like for any given square, you know, get a perfect plot fit graph of all those pixels, and like maybe some of them won't look really good, but perceptually for a user.
Okay, no, I was just curious, like on maybe a really high resolution screen, you could perhaps pick up, I don't know, like.
Yeah, you can definitely see artifacts. I mean, it looks like a JPEG, generally, like especially on the middle one there, you can see the really blocky outlines and stuff like that, where it can't find perfect colors. But hopefully it generally works. It's worse on alpha ones because you've got much less colors to choose from.
Alright.
Yeah. Cool. Right. Well, thank you. Should all go play puzzle trees or something? One more question?
One more question, second in right at the end. How do you handle the plethora of devices and sizes of screens for your game? Like you obviously have to extend your textures or anything.
So on iPhone we're a bit, on iOS we're a bit sneaky. We just all the textures are just iPad HD sized, and they don't take up very much RAM because they're compressed. So iPad HD gets full res images. Low phones get the same images, but they're compressed, so they're a little blocky anyway. But then they're scaled down, so you don't see the compression as much. On Android, we pretty much do the same thing. Like everyone gets a big set of images. I don't think we go quite as large as iPad HD size, because I don't think there are. Someone will probably correct me. Is there any iPad HD style resolution Android devices?
Next term.
There you go. They don't get that. If you've got one of those, don't play them. Don't tell anyone I said that.